Thank you for joining the October 24th, 2019 VOLTHA call. Just a reminder to everyone, these meetings are public and recorded, and we post them to our YouTube channel after we are completed. So please keep that in mind during the discussions and also during the presentations today. And then also, just if anyone has additional items you need to discuss with the group, please let me know. Our main topic today is going to be some continued discussion on transaction lifecycle. We do have the document for that Ken will be sharing, and he provided updates on the document in the shared folder, and the link to that hopefully was accessible for you in the meeting agenda that was sent out. With that, Ken, I'll go ahead and give you presentation rights, and we'll start today's discussion.
Okay, thanks.
All right, we can see your screen.
Okay. So last week, well, a few times now, we discussed about the transaction model between the core and the adapters, and we talk about pretty much sending a transactions, a request, and fire it, and then wait for the response asynchronously. So instead of going through all the small notes that we put in together, so I put a sequence diagram that kind of reflect a little bit of what we talked last week. So I'm just going to go over that sequence flow, and this sequence flow is really from there's two sequence flow. There's one from the northbound, meaning coming from OF agent or CLI, and there's another one coming from the southbound. So I'm just going to go through the northbound first. And by the way, thanks Mahir for your comments, and we're going to go over that as well. So pretty much what we discuss is, and correct me if I'm wrong, if the way I put the sequences doesn't really reflect what we agree on. So basically, like we'll get a northbound request, and here I'm putting the request. I'm forgetting all the northbound clients. I'm just starting from the API server here. So we get a request, and it's coming to a core, and we have two cores, but I'm just making things very simple. I'm just going to show one core and move from there. So we get a request to a core. So one thing that we're going to do is, it doesn't exist today, but we're going to publish an event on Kafka. Here you'll see there are two Kafka bus. There's the Kafka, which is between the adapters and the core, and I put another one I call it Kafka event bus, which is to publish events. Somebody somewhere is listening to it. So the first time we'll get the request comes in, we publish an event on Kafka, which says we get this transaction, and we publish the ID, and then the format of that message is to be determined how we want to do that. But the bottom line is we're just going to publish an event. And the moment we do that, we're going to lock that resource, whatever resource that we're trying to make the request on. Typically, it would be a device. And we'll lock that, we'll process the request within the core, and that could mean updating the model with whatever data we want. For example, if we're changing a device state, we're disabling a device, then we have to change the states. And then we're going to forward that request, assuming this is a case where we had to forward something to the adapter. We're going to forward that request to the adapter with a transaction ID. And today, we'll wait for a response from the adapter. So going forward, the moment we send it on Kafka and we guarantee the message reaches at least Kafka, what we do, we get an ACK from Kafka itself, and we're going to unlock that resource. And the moment we unlock it means another transaction can happen on that resource. and we're going to send back an act to whoever sends that request to start with. Like, for example, if it's a northbound CLI, they'll just get an ACK, and that ACK, all it means is the core has received the request, has processed within the core, has sent it out, and for certain requests, we'll get further responses going back. For some others, we're just not going to have other responses back. So once the core send it to the adapters, and here I put an event that we're going to publish on the Kafka bus to say at least the request has completed within the core. Doesn't mean it's completed fully, but it's within the core it has completed. And then we're going to wait for an adapter response. Like it can be immediate, could take some time. And then once we get the adapter response, there's two things can happen. It could be a success, means the adapter saying like, yeah, it's all good. Then we're going to publish on Kafka saying, okay, the transaction has been complete. And here I say do nothing else in the sense of, since we already sent an ACT to northbound, so far I've not seen any scenario where we need to send a success back again to any northbound system. If there's a failure, we're going to publish that failure on Kafka. And here I put process-specific failures, because depending on certain requests, some requests needs to have specific failure processing, others not. And then we're going to send back a failure event to the northbound system. And here I put, the only thing I put here is really for flow failures, because I don't see any other request where we'll be sending something directly to whoever have invoked it. For example, let's say we have a request that comes in that says reboot a device. So during that process of rebooting, the state change, there will be state change of the device. There will be state change on the port status. So if there's a failure, those states will remain in certain, the ports will be down and they will remain as down. So I don't see any point of sending a feedback back unless there's a reason to do that. The only one I say this, the only system that will be there and waiting for anything will be the OF agent, and that goes to owners, and that applies only to flows. So this is a little bit what we're planning to do in the core for northbound request. Any comments on that?
Yeah, the second Kafka, the K event bus, is that just a kind of a notification mechanism? That seems
yes.
Seems new, and I wasn't quite sure what precipitated that.
Yeah, this is just a notification mechanism. Like it's more like to keep track of how requests are proceeding through the system. Like the adapters also will be publishing to the same Kafka bus. So if we want to trace transactions with an ID, we can see it across components.
I see. But that doesn't affect the processing of the transaction. It's just kind of a notification. Got it.
Exactly.
Does it just contain the transaction ID, or does it contain information about the request, like the serial number?
That's to determine. Like at a minimum, it will need to have the transaction ID, but we can add any other information that we need. I've not defined how that event will look like, but it will be an event.
So the other difference here too is that ACK, I guess the first ACK, this is the ACK that's a reflection of guaranteed delivery in Kafka, right? This is Kafka itself ACKing rather than any library or any API, correct?
Exactly, yes. Like today we already have this ACK for Kafka, except we wait for the other ACK from the adapters.
I have, you mentioned that the failure event is only for flow changes, but we see that we need to handle also, device enable and device disable failures, especially the OLT.
Yes, so in that case, how you'd want that failure going back to, for example, if you have a CLI coming in and say disable a device, and let's say it fails, what kind of events you want to go back? Because the state of those devices will be disabled, and maybe there will be a reason update in the device data structure to say the disable has failed. Is that sufficient, or is there something else that we need to have there? Because mind you, if it's a CLI request, the CLI is not going to wait forever to get a response. It will just get a first act, and then after that, it's gone.
I think the admin state should not change, but maybe the operation state could move to failed or something. I mean,
yeah, it will.
That's the first thought that comes to my mind.
Yeah, I think the example here with CLI is the CLI itself. Let's say if it's Volt CLI or the legacy CLI, it by nature of its interactiveness is polling, if you will, except you're doing the polling yourself by getting the device state when you're ready for it. With regards to enable, this kind of is a tangent, but I always kind of felt like when we do an enable and the CLI, at least the legacy, happens to kind of sit there and wait for it to come back, there really is no need for it. I think it should just be a fire and forget kind of activity, and you need to either query again to figure out if it's ready or, yeah, it's interactive by nature.
Okay. So what would happen at the core if the device fails to enable? Would it stay enabled and because the device has failed to enable, or if you disable the device and the device was enabled first, and if it fails to disable, will it stay enabled in the core, or?
So what we said at one point of time, it was staying enabled. So what we did lately, we are going to put it as disabled, this admin state, because this is what has been requested. So admin state will remain disabled, and the operational state will be whatever the adapter set it to.
Okay.
So I think, for example, in this scenario, the core being the sole responsible party for admin state, like Ken said, would set it to disabled. It's just for whatever reason, if the core couldn't talk to the adapter to actually make it happen, the operational state would probably become unknown, right? So the adapter is gone or the adapter isn't answering, it would be admin disabled, oper state unknown. Just in that scenario, I think.
Yeah, that's correct.
Okay, got it. Thanks.
So do we see any other scenarios where we had to send a response to the northbound system other than the cases of flow failures?
Not that I can think of now. I guess, again, as long as we have the mechanism later, we can always add it. But for now, I think flows are really the only, notification mechanism that really needs it. The only other one is CLI, and CLI doesn't. So.
Yeah, exactly. Yeah. Okay. One question I have is, do we need to have a retry mechanism in the core? And here I'm taking the case of the disabled, where we try to disable something and then it's failed. Should the core retry the disable, or should the core just say, okay, the state have changed, it's disabled, and the operational state is whatever the adapters has put in, and leave it as is?
I don't think it should retry, in my opinion. I think the user of the system has to take a decision on what to do next.
Yeah, I think retrying from the client has the advantage that your client can also compensate for core failures or for API failures in the API server rather than implementing retry internally. Just do it like end to end.
Yeah, I think so. This is one situation where if, like we said earlier, if admin state was disabled and opper state was unknown, some northbound system like ONOS for flows, but it might not be for flows, it might be for just device management, could have the opportunity to say, okay, well, I need to try again if it didn't work or not, and prevent the system from being flooded with continuous attempts.
Yeah.
I think it's some ways similar to the core in that, or the ONOS and flows state where push the attempt. If the attempt fails, then report back through device state, and then some northbound system can, decide what it wants to do.
Yeah, I agree with that. It makes it much simpler instead of having a bunch of retries. Okay, so I think Maher, we had a few questions. I answered to those. Do you have any other comments on the question that you had? Let me see if Maher is there. Oh no, he's not there. Okay. So let me go through the southbound request. The southbound request follows the similar thing as the northbound request, in the sense of basically we'll have an adapter making a request. It goes to Kafka, it gets an ACK back, and it will put a notification event on Kafka saying, I send this request to core, and it will wait for the response. The core will get a notification from Kafka that it received a request. It will send again a notification on the other Kafka bus to say, okay, I received this event from the adapter. Again, it will just follow the same pattern as before. It will lock the resource, process a request, and update the model if it's required to. Then it will send a response to Kafka and a notification on the event bus. In the case of the adapter, it will receive a response from Kafka, and it will process the response. Like if it's a success, it will just do whatever it needs to do, or it's just a case of, or it could ignore it. In a case, for example, if it's a get device, for example, then it will have to do something with that response. If it's something like it was trying to update a device, then it doesn't need to do anything with the response, and only to know that it was successful. And yeah, go ahead. Yeah.
You might need to repeat what you just said. I think we lost you for a little bit.
Ah, okay. I don't know if my internet is like that though. So in the case, which part you lost?
Get device example. Get device is a success. Okay. Yeah.
Oh, okay. Okay. So today, let's take the example of a get device. Today, when an adapter sends a get device, it waits for the response fully. Like means the request will go to Kafka, to the core. The core will process it, send it to Kafka, come back to the adapter, and the adapter will process the get device. In an async way, if we do it fully async, it will send a request, and the adapter may choose to wait or do something else. And then once it gets the response back, it will process it. Or there's the other type of request where, for example, it goes and do an update of the device. So it will send a device update, and when it gets a response back, it pretty much will say either it's success or failure. If it's a success, chances are it doesn't have to do anything with that response. And if it's a failure, then maybe it will have to do something specific with it. So it's really the similar pattern that we want to have from the northbound or a southbound request. So any comments about that?
So I guess the biggest difference overall is the amount of critical section time between the locks on the core takes the adapter out of it, so that now the locks presumably should be locked a smaller amount of time, hopefully increasing concurrency and scale.
Yeah, that's correct.
Got it.
And there is something like today, when a adapter, and doesn't need just to be the adapter, the core also, when we use the Kafka library, and there's one function that we invoke, which is invoke RPC, and then we tell it like what RPC we want to call. And that invoke RPC is a synchronous call in the sense of, it appears to be a synchronous call. Basically what it does, it sends a request on Kafka and creates its own channel to wait for a response from Kafka. So on Kafka, it's async, but that library make it appears as if everything is synchronous. Do we want to keep that, because this make code very simple in cases where we really need to wait for a response? Or do we also want, maybe we also want to have a callback and a change in that API so that whoever's invoked that API specify a callback, so that instead of waiting for it, once you have a callback, your callback will be invoked after a response is received. And do we want to add a callback to that API, or do we maybe create another API for that? Any preference?
The appearance of the sync, right? This is given it's in the client library. From the point of view of the core, it's still async, right? The core treats it the async way. It just so happens that the client at the client side, the library on, I guess, the adapter's behalf is going to wait for it. So I don't know, just thinking through, it's like if it's a question of, do we always want to have the library wait, or do we want to have the library optionally wait and then maybe provide a callback? How difficult would it be to have, both depending on how you use it?
Yeah, it's kind of having everything done in a library, like the invoke RPC the way it is today, means the library itself is taking care of this async way of sending something and then waiting for a response, so that the code can be clear. For example, if you want to, you can do an update of a device in your code, just invoke RPC update device, followed by invoke RPC get device, for example. And you know that they will be processing one after the other. If we put a callback there, means when you do the update device, then you need to create your own callback somewhere to notify you that this update has been completed, and then you process to the get mechanism. So it's kind of like it's make the code.
My concern is we give this, if we give the client or whatever the capability to write essentially synchronous code, they will, and that will have impact on the performance of the overall system, right? I think we need to encourage writing in a more send something, wait for an event, or process the event when it comes in, as opposed to, essentially block your side of the code until a request. We'd enable bad behavior, essentially, or behavior that is not going to help the overall performance of our system.
Yeah, I understand that. My only concern there is I think we need to have the callback included there as well. The only thing I'm seeing today, I don't know if it's a question of not writing a concurrent code, but what I'm seeing in many code, it's no matter what, they need that synchronous nature of interacting with the core. So I don't know if it's the adapters in many cases will need that synchronous nature, or is it just like because the library is making synchronous, so that's why they're adapting this way?
Yeah. So from the callback perspective, that's fine. I mean, if I want to say, here I'm going to make this call, and here's a method to call when it's complete, that's fine. That's actually, I would say, is relatively keeping in line with a asynchronous kind of event-driven programming methodology. For the synchronous thing, yeah, I without a specific example, it's hard to discuss that, because just as you said, it might be that people are doing synchronous coding because they can, and it's because the library lets it, and it might be worth it to reevaluate those situations where it's required. If we give them a synchronous method, people will still use it. We'll just continue to use it, and we won't do that reevaluation. And again, I worry then that there's a overall performance impact on the code itself.
I second what David said. Maybe we could have some examples and then try to break that synchronous model there. Maybe that could give us a good starting point on whether to stick with this synchronous, simulating synchronous method, or maybe there are alternate ways to handle those kind of situations.
Yeah, like I think we need to include it, that callback mechanism. One thing I've noticed in some code where where there was some reliance on the, for example, there was a call to update the device status or operational state, followed by a get of that operational state from the adapter. So it was an adapter making an update followed by a get, and expecting that the get will contain the updates that was done before. So in a way, it's synchronizing all those requests, one after the other.
Yeah, see, that's where I'd like to evaluate the code and see why are they doing that to make sure it's required, right? It may be, and if it is required, but then if it is required, you can still say, great, this can be done by a callback. I'm not sure we want to, because of that, include a synchronous method.
Yeah, but do we want to make the callback optional? For example, like they can still invoke the same method. If they include a callback, then they get a callback. If they don't include a callback, then it's a synchronous call.
No, I wouldn't build, to be honest, my opinion would be don't make it synchronous, or don't include the synchronous calls until we're sure we really need them.
Yeah, I'm kind of leaning towards the callbacks. I think the adapters can sort that out on their own. There are some adapters that do need their own state machines internally to keep track of getting things sequenced right. I just think that in terms of interacting with the core, it might not need the core to be involved in that state machine behavior. It may be more of a inform the core of certain changes at certain moments that make sense. Port state is probably being one of them, right? We don't want to modify or make a port shown as available until we know we're ready for getting flows, right? If we say a port is available and we're not ready for flows, the flows won't push right. System's in an inconsistent state. It's trying again or what have you. So there's some sequencing that needs to be done, at least on the OMCI side.
Okay, so, okay.
But I just think that the core being tied up in that isn't as necessary, and I think a callback could help that.
Okay, we'll just make it if we just remove that synchronous behavior right away, and then and put the callback mechanism there, it will just be quite some changes in the adapters.
Yeah, I mean, well, it'd be good to shake out shake them out and see what happens in that case, right? There's,
Yeah.
you know, situations where it may become obvious that it doesn't really matter and we just cruise right on by, and there are others where it'll become very obvious and we'll deal with it in terms of what's broken.
No, I think it's a bit hard-handed, heavy-handed, or sorry. I think we need to gradually move to asynchronous behavior. There are a lot of active work going on, and suddenly removing the synchronous behavior might impact a lot of things. We could, gradually phase that out, but not on day one.
Yeah, just my opinion there, and I know it is disruptive, is if we don't do this now, the sync behavior will never change, right? If we say we'll do it gradually, that's great, but other things will take priority and it just won't happen. Unless we force a change, I don't believe it's going to happen.
No, sync is not bad always.
I agree. I agree.
Sync behavior. I think code reviews and expert opinion could help what could be sync behavior and what's not. But removing that option altogether, I don't know.
Let's do this. How about I add a new API in the Kafka library that is fully async. I leave the other one for a limited time, and so that we can experiment with it. And then if we're all okay to remove it, the synchronous behavior, we just remove it.
Okay.
David?
Again, I guess that's fine. I believe if there's just so many other priorities that it likely won't ever change, but okay. I'm happy if I'm proven wrong.
No, we can make it such a way that we say at a given release it will be gone. It will be gone. But
that's when things will change then at that given release. But okay.
Yes, I know where you're coming from. Well, we'll see. So the next thing I want to talk briefly is request traceability. It's something that we talk about this a long time back, but we never really do much about it. Is in order, if we want to send events on Kafka, whether it's a request coming in the core adapters, we need to have a transaction ID that flows it from beginning to end. Currently, we don't have a transaction ID that come with every request that is consistent from northbound to all the way down. Do we want to make those changes today? For example, in all the protos that we have, it's in a request to include an ID that follows a transaction from end to end, and keeping in mind that not all existing system have those transaction ID today. For example, we won't get that from Arnos. What's your opinion on that?
I think it's handy from a logging perspective as well, in that when something goes wrong, you can trace it all the way through the system. So I think this is a good idea. Though I suppose one wish would be that whatever the ID is, it has relevance beyond just VOLTHA. It would be nice to be able to trace operations through Onos as well and correlate this all together.
I agree with that. And what's the likelihood of having those changes to done in those northbound systems?
Well, we control Onos's apps at VOLTHA that are related to VOLTHA. So any calls we make to that, we could, any REST calls that they have that we're making, we could modify those to include a transaction. The question, I guess, is where does the transaction ID get created? And who's kind of the authorities for that, right? Because in any system like this, calls are being made all over it. How do we guarantee the transaction ID is essentially called on the outermost call?
It's whoever is originating that a transaction for the first time is the one that needs to create that transaction ID, and that could be in apps in Onus, or it could be from the adapter itself.
So there are quite a few off-the-shelf tracing toolkits, Open Tracing being one, and there are a few others. Are we thinking we'd integrate one of those tools that's already actually, I think it already does some of the gRPC, handling it on that side, handles some collection of data, or has tool sets that is interoperable with various tool sets that can consume the tracing data? Or are we going to try to roll our own system?
I have no idea about the open tracing tool, so it's something to look at. If it's something that does it outside of everything, it will give us some consistent tracing without us changing much of a code. Yeah, I'm all for that.
Yeah, I'm for using an existing system as well. And I don't know the open tracing, so the only thing that bothered me about that description was that it seemed to have its own reporting. And the question is, I'd like to have something that doesn't necessarily tie us to only one way to report it. I mean, if they integrate with things like, your standard ELK stack, that would be great. Versus I had to also use the open tracing UI to look at data. Does that make sense?
Yeah, as far as I can tell from the if you go to the website and look at their stuff, they're very neutral on both the client side and the consumption side. So, and it looks like it supports Elastic and a few other tool sets.
Is it used anywhere in code?
Currently, I don't think it is in the rest of code.
Okay.
I guess I'd rather have us not reinvent the wheel as well.
Yeah. Is it used? Where is it used? I guess is a better question, right? I don't want to be their first and only user necessarily. I mean, has it been proven? Is it proven? I guess is a question.
I can only speak to what I've read on the website because I haven't fully integrated it. It's something that we should probably look at and see what the other options are. It would be nice if this is a library you plug in and then it handles like annotating the transaction ID all the way through the system in some neutral way. Looking at their documentation, it looks like it supports all the languages we want, Go and Java and Python. So it would help with us being able to trace through like Onos, and then into VOLTHA.
So Zach, are you saying this thing would allocate transaction IDs for us and maintain transaction IDs, or do we still go with this proposal about making transaction ID an argument in our gRPCs?
I would think we should probably think more about the design. But I think having a transaction ID makes sense. The exact implementation is what we should probably spend some time looking at what other people have done.
If possible, putting it in the metadata or the context, kind of, as opposed to in the actual proto or the API would be good too. And again, I don't know what this does, this open tracing does or not. Also, understanding its impact or any impact would be interesting as well. In performance.
So are we still going to run into the issue then when we hit the inner adapter bus that metadata doesn't currently flow through that over Kafka? Didn't we run into that someplace else where metadata didn't go between cores and adapters?
Yes, for between cores and adapters, then we'll have to change the Kafka data structure to include that transaction. That meta transaction. There's already a transaction ID that goes in, but that's very specific for that request within the core and the adapter. So we need to include another one for this global transaction ID.
Yeah, I think that's where we'll have to look at this tracing package and see how they're actually adding the tracing information of the gRPC calls and how that would translate over what we're doing with Kafka.
Also, is there a spot in an OpenFlow message to put this transaction ID? Because not everything we're doing is proto-driven from northbound.
There is a transaction ID in the flow itself, but that's about it. So it's.
Yeah, I'm just thinking, you know, if we started this with the OLT app or the ONOS apps, you know, synthesize this transaction ID. You know, their only mechanism would be whatever they can shove into an OpenFlow message. You know, once we're in proto space, then it gets easier because we can define our own a little bit easier.
Yeah, we also have to think about how big this thing is. If it's something like a UUID, then it could be large and there may be more constraints on where we can put it, you know, in an OpenFlow message or something. Did you have any thoughts as to what this was going? Is it just like a 32-bit field, or is it something long like a string that's variable, or what kind of transaction ID were we thinking?
Yeah, I was thinking more like a UUID because it's anything else. I don't want to have a transaction ID that repeats itself somehow. So UUID seems to be the easiest one, but it could be anything. Like also in the case of flows, since there's already a transaction ID coming down, if we do our custom way of handling transactions for flows, we could use that transaction ID from ONOS all throughout, and then for other requests, use a different transaction ID. As an example.
Again, do we need to look at this package first and just understand what it does before? And I missed a little bit of the conversation. Sorry, so if I'm repeating stuff. But rather than go into implementation, why don't we take a look at this package and see if it does what we want and how it would integrate with our system, rather than say, you know, a transaction is going to be UUID. They may have already solved this for us.
Yeah, exactly. Yeah, yeah, definitely. Okay, so request traceability is a discussion on its own. Okay, so next one I want to talk about is when an adapter goes down. And here I'm talking about the adapter going down. I'm talking really in this scenario currently where we have only one instance of a given adapters. And I'm using that as an example. Like when we have multiple instances, then some of the logic will differ a little bit, but most of it, the gist is there. So basically what we'll have to do, we'll need to have some monitoring between the core and the adapters. And the monitoring will happen with Kubernetes. It won't go via Kafka because Kafka may die or something else may happen. So there would be this continuous monitoring that happen at a certain frequency between the core and adapters. So if there's a failure, and here I put a failure after full retries, we know like it's gone. Then we'll publish an event on the Kafka event bus to say adapter X is down. Then the core, any pending request, it will fail all pending requests. And it will mark the operational state of all devices managed by that adapter to a known. And it will also mark the operational state of the port to be unknown. And then it will send this port change event to Earth agent, and that will go to all the way to ONOS. If there is no failure, it will just say, so I'm good. So it will just restart that cycle the next. Is there any questions or concern about how the core process request and states when an adapter goes down.
What? I guess the question is about the heartbeat. Why are we doing a heartbeat as opposed to, hey, the core call makes a call? I guess going over, is it because we're going to Kafka so we don't know if it's not there? Is that the issue? I guess the question is, can't the core just make a call, wait for it to fail, as opposed to do a heartbeat? I guess I'm trying to figure out why to keep alive or between the core and the adapter, as opposed to let the adapter make calls, and if they fail, they fail.
Oh, from the core, you mean like any request that goes to the adapter, if it fails, fails?
Yeah, why? I guess I'm trying to understand the benefit of the heartbeat versus just letting requests happen naturally, and if they fail, they fail.
In the case, if we're going full async, first when we send a request, it goes to Kafka and comes back. We don't know if it have reached that adapter. And so we'll need to wait asynchronously for a response, and then that will wait. It will be very similar to that polling.
Because I guess at this point, right, so Kubernetes is already doing the heartbeat on the adapter, right? It's already calling the liveliness and the readiness probe every whatever. Can we just rely on that? And, you know, I guess the question is, well, if it's async, you know, at some point, presumably, the adapter will restart, right?
Yes.
So if we say, look, the core sends messages, Kafka manages the lifecycle of the containers.
You mean Kubernetes?
I'm sorry, Kubernetes manages the lifecycle of the containers. If a container dies, Kubernetes will restart it, and it will then continue to pull messages off the Kafka bus. Why are we trying to manage lifecycle outside of that?
Couple of things. If once a container restarts, it doesn't have any information about what are the devices managed. So it will need to have a list of that. So it will need to register itself again through the core and go through the reconciliation process before it can go and look at the messages that were on Kafka before. So we'll need to have, like, for example, maybe two different topics, one to register and one for all the other messages, and for it to do that. And second is, if the adapter goes down and we just wait for it to fail and then just the adapter comes back up, then how would owners and other systems above know what's happening to those device? Like, the way of saying, like, monitoring and says, okay, they have been down, is really to change the status of those devices, so that we can send a notification to owners and above to say that, oh, those devices are no longer available. Is your questions about how we are polling?
Okay, I get that. I get that second bit. I guess the question is, right, we're having VOLTHA now kind of reach into the domain of Kubernetes in order to update the state, right? If I'm in this environment and I want to know if the adapter's up, all I got to do is get my pods, right, in terms of the container being up or down. That's how I monitor it. You know, updating ONUS with the unavailable state, that's an interesting question, right? Does a device become, and we talked about this in the state conversation, a device becomes unavailable when the adapter is gone, or unreachable, or whatever we called it. And how does that get done? Is there any way to do that? Is there any way to feed that off existing mechanisms as opposed to build our own lifecycle management, kind of, or lifecycle monitoring in VOLTHA?
Yeah, one thing that I would like to see, I don't know, maybe the mechanism have it today, is there a way for any component to listen to states of state change of other components? For example, the core, is it possible for it to register with Kubernetes or any other probes and says, okay, from now on, I want you to tell me what's happening to adapter X? Is there a way to do that?
You can definitely watch events, give it access to the Kubernetes event channel. I mean, that's a little bit what the A router D was doing, right? When pods come into existence. So yeah, it's possible to do that. And so if we do that, we will know when pods change state or when pods go away.
Yeah, I don't know that I like the idea of too many components becoming Kubernetes aware. I guess I like the A router D approach that you were just outlining, David, where there's one thing that's kind of watching this and updating state. I mean, I guess where I'm going with this, I wouldn't necessarily want ONOS to suddenly have to have a Kubernetes API in it, and ONOS to be aware of what pod names go with what containers and adapters.
Yeah, agreed. And it should all be based on labels anyway, rather than pod names and specific names. And I agree with you, Scott. I don't think we want too many components aware of Kubernetes, just because, let's face it, in 6 months there may be, the new container management system that everybody must use. So we do have to watch out for those dependencies. So the question then becomes, if we need to monitor these events, these state events, is it something that we say, okay, great, we can create a monitor, whether it's A router D or an existing thing that says, look, this is our integration component into the environment, and it will have the authority to look for state change events, and it'll turn those into a Kafka message, and then our clients rely on kind of that internal Kafka messaging. I get that we isolate the dependency on Kubernetes, but it would be interesting to see, rather than create our own heartbeat mechanism, if we could leverage the container management system.
What if, so each of the containers, right, if done right, will have their own heartbeat or liveliness, readiness interface, and then, whatever process in the container, whatever it does to implement that is its business. Could we not use that same mechanism, just not go through Kubernetes to get to it?
But then we're keeping our own heartbeat. Then, first of all, each container is going to be called multiple times by everybody else who cares about its state. And each is going to have its own configuration of, okay, the last 3 liveliness probes failed, and I'll consider it dead if it's 4 out of 3 or
Sure. Well, I mean, and that's the catch. It's either we, have Kubernetes do it all, or we don't, is really what it comes down to. Because if we even say we have some new type of inter-adapter messaging that, let's say the Kafka API is just a heartbeat, just a back and forth, are you there? Yep. And then just ping pong back and forth continuously. I mean, it's a duplicate kind of activity either way.
Right, and I think, what I was talking about, and I'm kind of forming this on the fly, so it may not make sense at all, is, look, if we say there's a component, our integration component, VOLTHA integration component, whatever, and it sits there and has access to the Kubernetes event stream, and when it sees different events, such as pod goes unhealthy, pod goes unready, pod goes ready, whatever, pod stop, pod start, it can push those onto the Kafka bus. And so in terms of our components, such as the core, the adapters, trying to say, hey, okay, or the core is trying to say when an adapter is down, the core can listen to the Kafka messages, and so it's kind of acting independently of Kubernetes, right? It's using our own internal structures, but the thing that's actually doing the monitoring and initiating the event is Kubernetes, goes to our integration pod turns it into Kafka, and then we react to that. Therefore, while we're still letting Kubernetes deal with the lifecycle management stuff, we've essentially created a container management system independent abstraction around that.
So this is exactly what we did in XOS. We had a Kubernetes synchronizer that would pay attention to Kubernetes, and it would publish events on the Kafka bus saying, you know, hey, an ONOS labeled container restarted. You know, maybe someone cares about that, and then the ONOS synchronizer would say, yeah, I care about that. I'll reconfigure ONOS. So that there's precedent for that solution. I think it did work out for us.
No, I think I like it. If we have a system outside that will notify something on Kafka saying component X is down or up, and anybody who's registering for that get the message and do something with it, so I'm all for it.
I don't know. I kind of like. So I kind of feel like maybe tying it to like the registration mechanism today, right? When an adapter comes online for the first time, registers with the core knows about it through that registration. Would it be possible to have that registration have an expiration period? And if you don't call back with a duplicate registration again saying, I'm still here, then you're down.
Yeah, but unless you're going to say that registrations every 3 seconds, you could be actually down for minutes before that's triggered.
Yeah. Well, the only thing about that I don't like the registration message to have kind of two meaning. It's kind of it will be kind of a keep alive and registration at the same time.
Okay. Well, then maybe a different.
I think
it's in the same vein as a register. I mean, mostly because it really is about not only is the adapter there, but is the adapter there and is it able to communicate with the core? You know, and that communication mechanism is over Kafka, is the reflection of that registration. You know, and is there an unregistered? That's kind of the other thing too, is maybe an adapter cleanly goes down, you know, an unregistered would kind of tidy up that life cycle along with a, are you still there message.
I mean, one thing I thought we should have in the communication between the adapter and the core is kind of, when was the last time I heard from you, and keep that kind of state so that the core could say, you know, when I do a adapter list, I could see I've last got a message from this adapter 5 minutes ago, 2 minutes ago, right? And presumably, if there is a regular stream of communication between a core and adapter, that's all, you know, we could almost piggyback off that for kind of like keep alive, if you will, right? There's no reason to have a independent keep alive stream. You could just say, hey, look, you know, in reality, in a production system, I'm going to be hearing from this thing every 3 seconds. So I can just say, if I haven't heard from it in 3 seconds, likely something's wrong anyway. Again, I don't know
yeah, but that's almost have a duplicate system compared to what you earlier suggested about Kubernetes, right? Having something that publishes something on the Kafka bus.
Oh, I'm not, again, I'm just saying there's I'm assuming there's the regularity of messages between the core and the adapters is such that we'll know fairly quickly that something's wrong in that communication stream, right? Now, my assumption may be wrong. It may be not that we're seeing that frequent of messages between these things.
Currently, with whatever testing and everything we're doing, we're forcing those messages to go through. I don't know in a stable system how often those messages will go through.
Agreed, and that would be the issue. So if those messages aren't in a production system, are not frequent enough that we can just kind of say, we'll know right away when something's wrong, then I'm still back to kind of the Kubernetes approach. I don't think we want to have our own lifecycle management if we can get away without it.
So regarding the sort of steady state message traffic, there is stuff like initiating the buckets for performance metrics and stuff like the ONU. You would think, you know, if those are going every 15 minutes and new intervals are being started across 1,000 ONUs, that we would get fairly regular messages coming back from just that performance metric chatter.
But they don't go through the core, right? It's only between the adapter and Kafka.
Yeah, but I was thinking, isn't there still a message that says, you know, started? Well, yeah, I guess that doesn't go through the core. That's initiated by the adapter. Yeah. So forget my point.
Yeah, the only regular thing I see right now is when it's up and idle, list logical devices from OF agent. And then the occasional packet outs from RGs. And again, that just depends on the RG.
So Onos is also doing a get flows, right? And presumably that comes to the OF agent to the core to the adapter, and back up, right? And that's going to be happening fairly frequent, right? That's going to be happening fairly frequently.
What that request doesn't go to the adapter, it just goes to the core.
Yeah, I thought we were going to modify some of that so that we're actually going to reflect properly what flows. Maybe that's not in 2.x time frame. I thought the whole idea was to have proper reflection of what's actually on the device back up to Onos, and that's only going to happen if the adapters are doing a regular sync to what's actually on the device and flowing that up through the core.
Well, no, I thought what we discussed was more like when we are changing flows, if there's any failure, we're going to delete those flows from the core so that the logical flows on the core are the reflection of what are on the devices at all times, without needing sync between the adapters and the core.
Another discussion. Okay, let's table that then. In my mind, anyway. Okay, then again, if we're having regular messages and we can piggyback off that, or we'll know right away if things are bad, then we can use that. If not, I'm back to lifecycle management should be done by the container management system and not by us. Otherwise, we're duplicating.
Yeah, so I'm circling around to David's point too, that we've invested this time to implement these readiness probes and stuff, and it's all going through Kubernetes. Let's just use that, and then we get the readiness stuff done in one place, and we get it correct and one implementation.
Yeah, I agree with that. Like another reason, like we can't really look at messages like on a given request and figure out whether something fails or not is because we may have a request that goes to a device that succeeds and another device that fails, or a couple of them fails, and then do we just bring everything down? So I think we really do require an external system that does that monitoring, because we're going to make drastic changes if something wrong happens, like for example changing all the operation state of all devices to unknown. That's quite drastic.
Yeah, I mean, I kind of agree there. VOLTHA should. I'm back to let VOLTHA core make calls. Something else is going to be monitoring the life cycle of these things. If they want to make a big change, like reboot a node or reboot whatever, that's outside of VOLTHA. The only reason VOLTHA, I guess, should be listening to it is if it wants to start marking things as unreachable. And I'm kind of torn by that, really, to be honest. When things become unreachable from a VOLTHA perspective, is it going to really monitor the adapter and notice it's down through Kubernetes and say, okay, it's unreachable? Or does it just keep making calls and look at response times for those calls, and when they've hit a certain time, basically say, look, I'm having communication problems, right? I'm leery about VOLTHA start monitoring its components and reacting to it, to be honest, even marking things unreachable this morning. Maybe that'll change by this afternoon.
Like, me, I think having an event from Kafka saying an adapter is down, I think it's better if you follow that. My question is, do we need to take that drastic action of marking all devices to be operationally unknown, and as well the states of the ports to be unknown, and force those events up all the way to owners?
Yeah, that's the thing, is if it's an adapter blink for like upgrades or whatever, I mean, do we really want ONOS to start pulling flows and affecting data plane when we really don't have to?
Mm-hmm.
Maybe that's something where there might be a way for the operational state of the device to be marked as unknown, but then we don't, we render it some way so that you can see it, at least in VOLTHA, to know that there's something, not quite right. But then don't inform ONOS unless we have positive confirmation that we really need to start tearing things down.
Yeah, there could be like a maintenance mode flag on a device that says it's undergoing maintenance. It might be flaky, but it's expected to come back up.
But if the adapter's down, it doesn't matter if we inform ONOS, because ONOS won't be able to change the flows on the device anyway, right? Because ONOS will say, oh, let's start tearing things down. They'll go to ONOS, or they'll come to VOLTHA, and VOLTHA will try to go, well, I can't do anything about it, but thank you very much, because my adapter's down.
Right.
So there's no value in actually telling ONOS.
I'm kind of leaning towards almost just letting the state in Kubernetes kind of show you that state, and yeah, maybe we don't get too creative about what we do in VOLTHA.
Right, that's why I'm kind of circling back to, let Kubernetes manage the lifecycle, report when a container's down, and you've got commands to do that, and that can integrate with another management system or external system, and let VOLTHA just do requests. And yes, we can track when's the last time we talked to an adapter, but other than that, we don't do anything. And we don't need a Kubernetes to VOLTHA or to Kafka event system.
Yeah, and Ken, isn't there already a mechanism in core when the adapter re-registers, that the adapter was down and it came back, and then you could do all these steps, but otherwise you wouldn't need any heartbeat mechanism?
Yeah, currently we already have the mechanism of when the adapter goes down and come back up, all the reconcile process is already there. But I recall there was a need at one point of time during the discussion where we were talking about if the adapters goes down, then we need to inform owners about it. I don't know if it's just a few months ago, or is it something that also was part of some of document or not?
I think it was recently we talked about that, but just as I said, just thinking now, we inform ONOS that a device is down or adapter is down or whatever. ONOS we can't do anything. The adapter's down. So what's the value other than letting people see it via Kubernetes or whatever their management system they're doing? There's not much we can do about it. So I'm kind of, can we just, I guess, table this until it becomes an issue in some sense, right? Let Kubernetes manage the life cycle. We don't do anything with it. And if it becomes an issue, let's figure it out. But I'm not sure it's an issue yet. It may just be that we
get reconcile to work. If reconcile works and an adapter goes away and comes back and the adapter is still of its mind, then nothing has to change, right? The adapter is still as good as it was before when it crashed and came back. So assuming reconcile did its job, then it should be a non-event. It shouldn't be falsely or aggressively advertised to too many systems to have them come up with a bad decision or a drastic decision.
It also means we don't have to do any work, which is a good thing.
Yeah.
Oh yeah, well that too.
I think we still need that event from Kafka to say that the adapter is down, so that the core can reject any of a new request on that adapter. Otherwise, if we don't have any system like that, we may get in a situation where the adapter is down for a longer period of time, and we're getting all kind of requests coming in, not found. We're sending all those on Kafka, and we're waiting asynchronously for a response for a long time.
Admin down the device if that's the case, right? The only time an adapter should be down for an extended period of time is if the operator knows about it. Other than that, it's a fault in the system and everybody's working their hardest to get it up and running, right? And so there's external systems to deal with that. If the adapter is going to be down because for a day, the operator is going to know about that if it's a maintenance issue, whatever, and find some way at that point to administratively deal with it, as opposed to deal with it from an event system, right? I think we might be overthinking this one. We're trying to solve a problem that we don't even know exists yet, and I'd rather say let's let it go and see if it actually becomes a problem, rather than spend effort here.
I'm okay with that.
So maybe in your diagram here, those two bottom arrows, port state change events, those go away. Maybe that's really what. Yeah.
But do we need to change the state?
Oh no. Yeah. Maybe we don't need to do either then.
Yeah.
No state change are required.
So do we need to talk to?
Do we need a diagram?
I mean, the one thing we do have to, I mean, the adapters do need your registration, and I've already found out, and I'm kind of working on it. The adapters also, or the registration also has to deal with the fact that, you know, adapter version 1 was registered, and now, hey, look, I've got adapter version 2, and the core has to deal with, hey, there's been an adapter upgrade and reconcile with that new version of the adapter versus the old version. So those things we have to deal with, but life cycle things in terms of state changes, yeah, I'd punt.
So do we need to talk to the ONOS app people about this? Because one of the things we're doing is exporting that virtual abstraction, and that virtual abstraction does have, you know, ports go up and down. So if we're eliminating the arrow that ports can go up and down, does that impact the ONOS apps?
I think this is only for adapter fail, right? In the case where an adapter is running and the physical device goes away, or the physical device reports some issue in its situation, we still absolutely have ports going down. It's just when the adapter goes down, we really don't know what happened to the ports.
Because the hardware could still be sitting there forwarding messages and stuff just fine.
Absolutely. Yep, absolutely. So I don't know. I think maybe we are overthinking this one.
Yep. Well, it's auto-generated from the conversation that we had a while back. So it's if we don't need it, well, I'm all for scrapping it. Other than that, that's it. So what I have in the document. Any other general comments?
So is this finally enough for us to, I guess, move forward? Are all the questions answered in terms of device state and transaction and locking? I guess, you know, we've done this conversation probably like 5 or 6 times now, and I'm hoping this is it. I think we got it. I just want to make sure we all agree on that.
Oh, come on. We can do this 3 or 4 more times. It's fun.
And we'll change it again.
Yeah, as I said, this afternoon I might have completely different opinions.
Yeah.
So do we want to build in David's suggestion about keeping track of the last time a message was received? It does seem like that's useful from a diagnostic perspective to do a, you know, a device list and, oh, I heard from it 3 hours ago. Even if we don't, you know, make operational decisions based on it, it's just informational.
I think that's useful.
Yeah, if we want to have
my
that
idea, so I think it's useful.
If we want to have that, then we need to change a change in the proto to allow that, and then to make it persistent.
Why a change in the proto? It's just every time the core every time the core gets a message back, it just says, "Oh, I got a message back. I update my data." I don't think there's a proto change.
No, but if you want to keep because how do I know? Like every time you get a new message on the device, it just says this is the time that I receive it. Is that enough in terms of tracking, or do we want to? If a call goes down and comes back up, and then we want to have that data to be persistent.
Right. I'm not talking persistence. I'm not talking anything. Well, at least in my mind, I wasn't talking persistence or anything. It's like, look, every time I get a message back, I could maybe track in my in-memory. This is the last time I heard something about this device. Track in-memory. This is the last time I heard something from the adapter. That's all it means. So if no proto changes, no persistence changes, it's just live diagnostic information.
Okay, and how an external system will have access to that information? Do we just every time we get something put the log out, or how do we do that?
Okay. Yeah. Okay. You win. We're gonna have to modify. We'd have to modify the protos to at least the adapter protos, because originally when I was thinking about this, it wasn't going to be per device. It was going to be just keep track of when's the last time I heard from the adapters. When I do adapter list, for example, I could see that, and that means we have to change the adapter proto.
Mm-hmm.
Put it on the backlog. I mean, it'd be nice to have.
Okay.
I agree, but it's a low enough priority that
Well, we're changing the device. We're changing the device proto anyway for the device state, port state changes. So, I mean, we're already changing protos anyway.
Mm-hmm.
Okay, if we're already changing protos and we can add it in there, then we can decide, do we just, where do we want to keep this last message time associated with? Is it just with the adapter, or are we going to put it on other things as well? Again, as I've thought about in the past, it was just a timestamp on the adapter, not a timestamp per device. Also, are we going to, during this proto change, are we also going to do the change so that the Java generator can generate valid code?
In Java generator?
Yeah, apparently it wants certain naming that doesn't quite fit with what we're doing.
Yeah, I still believe it's a bug in the generator, but if we're going to want to be able to generate stubs for Java, we're going to have to modify our protos.
I remember a long time back, there was some concern about the way it was generated for C++. I think it was with Nokia adapters. I don't know if it's the same problem or not.
I don't know either.
It might be worth addressing both of those at the same time. I know at some point, like right now, I think the agent will pull the proto file from the shared repository. It's just we don't check in C or C++ generated stubs.
Mm-hmm.
So I mean, maybe that gets looked at the same time with the Java ones. Though I'm kind of trying to figure out what the need for the Java ones. Was it because of the misunderstanding of XOS, or was there some other need?
Hi, Matt. Are we talking about the Java support of the protos? I'm sorry, I joined the meeting very late.
Yeah, we're talking about the Java support of generating gRPC stubs for Java, and the fact that I think it was the enum and the message or somehow was having name conflict.
Yeah, I'm developing a module on VOLTHA, which is Java, and we want to implement the Java gRPC APIs on top of the VOLTHA. But the problem is some name of the messages and the enums in the messages are same. So the Java generator generates the classes and the enums in them with same name as it's expected. But the Java compiler do not compile these codes. So it gives error and say that this you cannot define, this enum name same with the class name, and some errors that represent this kind of thing. Okay, so we cannot compile the generated Java codes, and so cannot use them. That's the problem.
Yep. Again, my personal opinion is if the generator is generating codes from valid prototypes or protos, and it's generating code that can't compile, there's a bug in the generator. That being said, if we're going to be mucking with the protos anyway, we might as well make this change.
And it's just the enums, I guess, only the enum fields that have this problem.
Yes, it is enum, and the specific parameter which is descriptor. I mean, Java does not want to see the descriptor name in as a parameter in class, as an attribute in class. There is only one field descriptor in a class, and you should change it. The other ones are the names of enums and their methods.
I mean, I think it's manageable. I think we can manage that.
I think a while back, like when the protos were first created, the enums, the way they were made was a little bit different. It's that way, I think if you do the Java compile, it will work because it was not moving the message. But I think we had to make it to change the enum to put them in a message. I can't remember exactly why. But I think there was a requirement for that. I don't know if it was because of Python or because of gRPC compiler. I have no idea. But something to look at.
I think it was because of C++ compilation problems. I saw a similar thread in somewhere while Googling. Probably we put the enums in message structures because of C++ compilation problems.
It could be. It could be that the Java and the C++, maybe. Hopefully, we're going to have a proto that satisfies both.
Yeah, if not, we're in trouble. Well, if not, I mean, again, these are bugs in the generators, right? And at some level, we have to push back on the generator and say, fix it. While we try to make our clients as happy as possible.
It seems that they don't want to fix them. I tried to find some threads, some bug opens, but the developer says if we try to change for those specific things, then we have to do specific things in our code, and we don't want to do that in our code.
Okay. Again, I'm from this perspective, we're going to be changing the protos anyway. If we can change the protos to make the Java generate correctly, that's fine. If, however, we do that, and all of a sudden that makes the C++ generator generate bad code that won't compile, then we're in trouble. So we're going to have, I think, before we make any of these changes around this, we're going to have to find out who's generating what from the protos today, so that we can guarantee that after we make the changes, those are all working.
I think once we change the problems, if we fix the problems, then no one will have further problems, because it seems already weird that having a same name in a class, so like log level there's an enum log level inside of log level message. It already seems weird a little bit.
I mean, so it sounds like this is a duplication of names, right? If we made sure that any of our fields and our messages and protos don't duplicate names, we would work around this, right?
It may, but I thought, the point of having to put enums in messages, if that was because the C++ generator required that, we might have to keep that kind of strange construct. But yeah,
well,
we
I guess
can still change the name.
The difference, and is it just the name of it that's the problem?
Yeah, I don't know.
Yeah, I think we have to experiment with it and see like what was the actual root of the problem. Like if you look at the protos today, you'll see a lot of annotation. For example, you see a lot of yang annotations, and that was to really like bypass the two names, one name within another names. So it's there has been a lot of kind of workaround around this. So I think we need to experiment and see. But we have only 3 minutes left. So what I'm going to do, I'm going to update the documents, and also I'm going to create the JIRAs following the two set of discussion that we have on device states and the transitions, and then we'll go from there.
Okay, thanks, Ken. And as you said, we just have a few minutes left here. Any last comments from the group for today? Okay, and then I think I heard we also are going to need to have a separate discussion on request traceability. And Zach did provide a link in chat to open tracing so people can go take a look at that. And it sounds like some investigation needs to happen. So let me know when a good time would be. We can do that afterwards. We can set up, just give people a chance to take a look at things and then set up a discussion on one of these calls once people have enough background information done. Okay, and Zach also provided a link to a document as well with more details. Okay, thanks, Zach. Any other comments from the group? Okay, I'll go ahead and stop the recording and we'll close today's meeting. Thanks, everyone.